Welcome. Today, we are looking at chemical equilibrium. This is a key topic in your chemistry exams for SS2. Pay close attention. Let us begin. First, let me explain what chemical equilibrium is. Chemical equilibrium is the state in which the concentrations of reactants and products remain constant over time. It occurs in reversible reactions. A reversible reaction is a reaction that can proceed in both directions. The forward reaction converts reactants into products. The reverse reaction converts products back into reactants. At equilibrium, the rate of the forward reaction equals the rate of the reverse reaction. The concentrations do not change. However, the reaction has not stopped. Both forward and reverse reactions are still occurring. They are occurring at the same rate. This is called dynamic equilibrium. Dynamic equilibrium is important in many chemical and biological systems. It is essential for understanding acid-base reactions, solubility, and many industrial processes. Now, let me explain the characteristics of dynamic equilibrium. Several characteristics define dynamic equilibrium. First, it is a closed system. No reactants or products can enter or leave. Second, the concentrations of reactants and products remain constant. They do not change with time. Third, the forward and reverse reactions occur at the same rate. Fourth, the equilibrium can be approached from either direction. The same equilibrium state is reached whether you start with reactants or products. Fifth, the equilibrium is dynamic. The reactions are still occurring. They are not stopped. Sixth, the equilibrium is not affected by the presence of a catalyst. A catalyst speeds up both the forward and reverse reactions equally. It does not change the position of equilibrium. It only helps the system reach equilibrium faster. Now let me explain the equilibrium constant. The equilibrium constant is a number that expresses the ratio of products to reactants at equilibrium. For a general reaction, AA plus BB, CC plus DD, the equilibrium constant expression is Kc equals concentration of C raised to the power of C times concentration of D raised to the power of D divided by concentration of A raised to the power of A times concentration of B raised to the power of T, power of B. Kc is the equilibrium constant in terms of concentration. The value of Kc indicates the position of equilibrium. If Kc is very large, the equilibrium lies to the right. The products are favored. If Kc is very small, the equilibrium lies to the left. The reactants are favored. If Kc is around 1, the equilibrium lies in the middle. Both reactants and products are present in significant amounts. The equilibrium constant depends on temperature. It changes with temperature. It does not depend on concentration or pressure. The value of Kc is constant at a given temperature. Now, let me explain Le Chatelier's principle. Le Chatelier's principle states that if a system at equilibrium is subjected to a change, the system will shift to counteract that change. The system will adjust to minimize the effect of the change. This principle is very useful for predicting the effect of changes in concentration, pressure, and temperature. It is used in industry to maximize the yield of products. It is used in biology to understand how systems respond to changes. Le Chatelier's principle applies to all equilibrium systems. Now, let me explain the effect of concentration on equilibrium. If the concentration of a reactant is increased, the equilibrium shifts to the right. More product is formed. This consumes the added reactant. If the concentration of a product is increased, the equilibrium shifts to the left. More reactant is formed. This consumes the added product. If the concentration of a reactant is decreased, the equilibrium shifts to the left. More reactant is formed. If the concentration of a product is decreased, the equilibrium shifts to the right. More product is formed. For example, in the reaction N2 plus 3H2 2NH3, increasing the concentration of nitrogen shifts the equilibrium to the right. More ammonia is produced. Decreasing the concentration of ammonia also shifts the equilibrium to the right. More ammonia is produced. Le Chatelier's principle predicts these shifts. Now, let me explain the effect of pressure on equilibrium. Pressure only affects equilibria involving gases. If the pressure is increased, the equilibrium shifts to the side with fewer moles of gas. This reduces the pressure. If the pressure is decreased, the equilibrium shifts to the side with more moles of gas. This increases the pressure. For example, in the reaction N2 plus 3 H22 NH3, there are 4 moles of gas on the left and 2 moles on the right. Increasing the pressure shifts the equilibrium to the right. More ammonia is produced. Decreasing the pressure shifts the equilibrium to the left. More nitrogen and hydrogen are produced. If the number of moles of gas is the same on both sides, pressure has no effect on the equilibrium. For example, in the reaction H2 plus I22HI, there are 2 moles of gas on both sides. Pressure has no effect on the equilibrium. Now, let me explain the effect of temperature on equilibrium. Temperature affects the equilibrium constant. For an exothermic reaction, increasing the temperature shifts the equilibrium to the left. The products are favored at lower temperatures. For an endothermic reaction, increasing the temperature shifts the equilibrium to the right. The products are favored at higher temperatures. For example, the reaction N2 plus 3H22 NH3 is exothermic. Increasing the temperature shifts the equilibrium to the left. Less ammonia is produced. Decreasing the temperature shifts the equilibrium to the right. More ammonia is produced. However, lower temperatures also slow down the reaction. A compromise temperature is used in industry. In the Haber process, a temperature of about 450 degrees Celsius is used. This is a compromise between yield and rate. Le Chatelier's principle explains these effects. Now, let me explain the effect of catalysts on equilibrium. A catalyst does not affect the position of equilibrium. It does not change the equilibrium constant. It does not shift the equilibrium. A catalyst speeds up both the forward and reverse reactions equally. It helps the system reach equilibrium faster. It does not change the final concentrations. Catalysts are used in industry to speed up reactions. They allow equilibrium to be reached more quickly. They do not change the yield. For example, in the Haber process, an iron catalyst is used. It speeds up the reaction. It does not change the equilibrium position. The catalyst allows the reaction to proceed at a reasonable rate at a moderate temperature. Now let me explain the industrial applications of Le Chatelier's principle. Le Chatelier's principle is used in many industrial processes. The Haber process produces ammonia. The reaction is N2 plus 3 H22 NH3. The forward reaction is exothermic. High pressure favors the forward reaction. Low temperature favors the forward reaction. However, low temperature slows the reaction. A catalyst is used to speed it up. The process operates at high pressure and moderate temperature. The contact process produces sulfuric acid. The reaction is 2SO2 plus O22SO3. The forward reaction is exothermic. Low temperature favors the forward reaction. High pressure favors the forward reaction. However, the reaction is already at high pressure because of the gas volumes. A catalyst is used. The process operates at moderate temperature. Le Chatelier's principle helps optimize these processes. Now let me explain the concept of equilibrium in daily life. Equilibrium is important in many everyday processes. The solubility of gases in liquids is an equilibrium. Carbon dioxide in soft drinks is an equilibrium. When you open the bottle, the pressure decreases. The equilibrium shifts to release gas. The bubbles come out. The pH of blood is maintained by equilibrium. The carbonic acid bicarbonate buffer system maintains pH. Acid rain is an equilibrium. Sulfur dioxide dissolves in water to form sulfurous acid. The equilibrium determines the acidity of rain. Equilibrium is essential for life. It is essential for industry. Understanding equilibrium is essential for chemistry. A common exam question asks you to define chemical equilibrium and explain dynamic equilibrium. Here is a sample answer. Chemical equilibrium is the state in which the concentrations of reactants and products remain constant. Dynamic equilibrium occurs when the forward and reverse reactions occur at the same rate. The reactions are still occurring. They are not stopped. The concentrations are constant. Dynamic equilibrium is a closed system. It can be approached from either direction. A catalyst does not affect the equilibrium position. Another exam question asks you to state Le Chatelier's principle and apply it. Here is your answer. Le Chatelier's principle states that if a system at equilibrium is subjected to a change, the system will shift to counteract that change. Increasing concentration of a reactant shifts equilibrium to the right. Decreasing concentration of a product shifts equilibrium to the right. Increasing pressure shifts equilibrium to the side with fewer gas moles. Increasing temperature shifts equilibrium in the endothermic direction. A catalyst does not affect the equilibrium position. Another exam question asks you to write the equilibrium constant expression for a reaction. Here is your answer. For the reaction AA plus BB CC plus DD KC equals CC DD AA BB, the concentrations are equilibrium concentrations. The exponents are the stoichiometric coefficients. Kc is constant at a given temperature. It changes with temperature. It does not depend on concentration or pressure. Let me give you a quick summary. Chemical equilibrium occurs when the rates of forward and reverse reactions are equal. It is a dynamic process. The equilibrium constant expresses the ratio of products to reactants. Le Chatelier's principle predicts the effect of changes in concentration, pressure, and temperature. Concentration changes shift the equilibrium. Pressure changes affect gaseous equilibria. Temperature changes affect the equilibrium constant. Catalysts do not affect equilibrium position. Le Chatelier's principle is used in industry to optimize yields. Practice these concepts. When you have them down, move to topic 5.